Hey everybody, it's Mr. Kolu here with some Kolu Math. Today we're going to dip our toes in the algebra waters by looking at very simple equations, what we call one-step equations. When I started teaching, my students were pretty good in middle school. You know, they would measure angles, calculate area, no problem. But when I put this on the board, they'd freak. And I could never really figure out why. It's just a variable. And a simple definition for variable is a letter that represents an unknown value. You know, X or Y or A or B. And these variables, well, they're just mysteries. They're just puzzles. And when you see an equation like this, you should really start thinking about it like a sentence like this. When you see that sentence, you've already solved the problem. Your brain just does it automatically. It's something you like to do. It's something you'll do naturally. So here, we have to make these X's seem a bit more friendly. And, well, maybe we're getting ahead of ourselves a little bit. Let's take a look at a really easy equation. So what does this mean? What are those two little lines in the middle trying to tell me? Well, historically, people have thought about equations like balance scales. And you can see one over here. When the two sides are the same, it's green. When weight is added to one of the platforms, the scale turns red, indicating that the equation is unbalanced. When you remove that weight, it goes back to being in equilibrium. So let's take a look back at our equation over here. 3 plus 3 equals 6. The first part of that equation is 3 plus 3. So let's go ahead and model that on our scale. You can see the scales become unbalanced. We have to finish the equation to make it balance. On the right-hand side, we have 6. So let's go ahead and place a 6 on the right-hand side of our scale. And you can see they balance each other out. 3 and 3 is 6. They're the same. But we're actually saying something a bit bigger here. See, that 6 on the right-hand side, that's not really a 6. That 6 is actually 6 little 1 blocks. And the 3 blocks on the left, well, each of those blocks is actually worth 3 1 blocks. So instead of thinking about it as adding 2 3s and getting a 6, you can think of it as combining 2 sets of 1s. So what this equation is really telling you is that 3 1s plus 3 1s equals 6 1s. And this may seem kind of trivial, but remembering integers as groups of 1s is really helpful for algebra. And that is the mystery of X. We're trying to find out how many 1s are inside that X because it's different in every problem. It might be 1 in one problem, and the next problem X might have 3 1s inside of it, and in the next problem, X might have, well, a bunch of 1s in it. So that's sort of what we're trying to figure out, how many 1s are in X. So let's look at this really easy algebra equation. You might be able to do this in your head, but let's examine some of the concepts at play here. We'll start by modeling on the scale. We have 1x and 3 1s on one side, and on the other side, we have 7 1s. So to solve this, what I might do is try taking 1 from each side at a time. I'll take 1 from both sides, and it's still in balance. If I take the same thing from both sides again, it's still in balance. And I'll try that one more time, and I'm still in balance. And look what the scale is telling us. 1x is 4 1s. X equals 4. And how did we get that? Well, we subtracted 3 from both sides. Let's take a look at the numbers. See, what we did was we subtracted 3 from both sides, effectively canceling out the plus 3 on the left, and that left us with x equals 4. So algebra is sort of the process of removing clutter from the side with x. I want to make this equation tell me what x equals. And the way I do that is by removing the plus 3 by subtracting 3 from both sides. This is the basic process of solving algebraic equations, getting x isolated on one side. Okay, here's another equation, x plus 8 equals 16, and we want to deal with that plus 8. So we're going to deal with it by removing 8 from both sides. We get x equals 8. Okay, pretty simple. Let's take a look at a different kind of problem. X minus 2 equals 3. Okay, this is going to be a little different. Well, let's head on over to the scale and start modeling. So we've got an x in there on the left-hand side. then we've got that minus 2. Well, how are we going to deal with negative numbers? Negative 2. I mean, we know that 1's way down the side that they end up on. Maybe negative 1's lift up the side. And actually, we can model that using these two negative 1 balloons. The scale is still unbalanced because we haven't completed the equation. On the right-hand side, we have 3 1's. There, now we're balanced. But what are we going to do with those negative 1 balloons? Oh, man. Actually, believe it or not, a negative 1 balloon can be popped by a 1 block if you throw it at it just right. They actually meet and cancel each other out. So let's add another 1 to that side. Okay, but now we're unbalanced because we removed those two negative 1 balloons that were lifting us up. Now, we did this before, but we didn't explicitly mention it. It's an old rule for equations. What you do to one side, you must do to the other. So taking a look back at the scale, we added 2 1's to the left side. We're going to have to add 2 1's to the right side. And look at what the equation is telling us. X equals 5. All right, so if we go back to the math on the board here, the item to clear from the x side is the negative 2. And I can do that by adding 2 to cancel it out. So I have x equals 5. Take a look at another one. I have an x minus 5 here. To deal with that negative 5 by adding 5 to both sides. And that tells me that x equals 6. All right, let's take a look at another type here. Here we have 3x equals 9. Oh, man. Well, that 3 out in front there, that 3 is what we call a coefficient. And a coefficient is a number that multiplies a variable. So in the case of 3x, the coefficient is 3. And by now you've seen many different ways to show multiplication. The old x style, the dot style, and the coefficient style. The thing is, all 3 of these things are worth the exact same. They're all 3x. And we don't really use the first style anymore because the multiplication symbol is easy to confuse with x. Isn't that just like math teachers to teach you something and then later tell you not to do the thing they taught you to do? I guess they probably would have used the dot, but you might have gotten that confused with a decimal point. Well, anyway, let's move on. So 3x equals 9. Let's go on over to the scale and try modeling that. So on the left side, we have 3 x's. Okay. And on the right side, we have 9, or 9 1's. And that balances out as an equation. So I guess what I would do if this was real would be take 2 of the x's away and then start removing 1's from the other side until it balanced out. But the problem is you can't do that with a math test. You don't have a scale in front of you, and you certainly don't have an x block. So we have to accomplish the same effect conceptually. So, let's split the left side up here into 3. And I can actually do that to the right-hand side too, because there's 9. Wait a minute. What if I divide both sides by 3? Well, that kind of makes sense. Let's take a look at it on the board. So I have 3x equals 9, and if I divide both sides by 3, well, that leaves me with x equals 3. Cool, huh? We can actually think about this in another way. If we go back to the equation and think about breaking these up into 3's, we're actually taking 1/3 of both sides. And if we go back to the blackboard here, we can take a look at the equation. 3x equals 9, we'll multiply both sides by 1/3. We also know that's true because of the rules of multiplication. 1/3 times x is the same thing as dividing x by 3. And in a more general sense, 1 over any number times a variable equals that variable divided by that number. Notice the numerator is always 1 in that case. Okay, so we have 1/3 times both sides of the equation. Let's go ahead and write this out kind of longhand style. 3x equals 9. Let's multiply both sides by 1/3. And to do that, we're going to have to convert 3x and 9 into fractions. So we'll get 3x over 1 equals 9 over 1. Now we're going to multiply both sides by 1/3, follow the rules for multiplying fractions, and then reduce those fractions. And we figure out that x equals 3. And it's probably good to talk about the work we've done here. Each new line represents one mathematical move that we did to move to the next step. When we chart out our math work this way, someone can follow and see the exact motions we made to solve the problem. Okay, well, this problem should be easy now. we have to deal with that 6 out in front. And the way we're going to deal with that 6 is by dividing. So we can divide both sides by 6. 6x over 6 equals 36 over 6. And then we reduce those fractions to find x equals 6. Really simple. Let's go ahead and think about it the other way. So instead of dividing by 6, we'll think about it as multiplying it by 1/6. So 6x equals 36, and we follow through the math process just like we did before. Now, a lot of my students would have complained and said, "Why are you doing this? You're confusing me. I just want to divide by 6. Well, that's fine. If you just want to divide by 6, go ahead and do that. Okay, wow. 1/2 x equals 3. Well, this is going to be a little tougher here. How are we going to model this? Let's move over to the scale here and attempt to model this. So half of an x equals 3 1s. So I have half of an x. How am I going to figure out what a whole x is? Okay, well, here's an idea. If I double what's on the left side, I'll go from having half an x to having a whole x. Well, that's going to unbalance me again, isn't it? Well, what do I do to the other side? Oh, right, yeah, remember the rule. What I do to one side, I must do to the other. So since I doubled the left-hand side, I'm going to have to go ahead and double the right-hand side. And if we go back to the math, you'll see 1/2 x equals 3. We took both sides, and we multiplied them by 2. Let's go ahead and solve that out. So I have 1/2 x equals 3, multiply both sides by 2, convert everybody into fractions, do the fraction multiplication, and then reduce your fraction, giving us the answer that x equals 6. But we could also think of this problem in a different way. Instead of thinking about it like doubling the left side, let's think about it like adding half an x. So I've got 1/2 x plus another half of an x, and on the right-hand side, all I would have to do is add half an x as well. Now this may seem kind of foolish, but let's take a look at the math and look at what it shows us. So here's our original equation, half of an x equals 3 1s, and we're going to add half an x to both sides. And here's what that looks like when we write it out in the equation. Okay, but we know something special about half an x. We know that 1/2 of an x equals 3 1s. So we can replace that half of an x in the top right corner there with 3 1s. Now this may seem like a ridiculous way for solving this problem, but what it does show you that as long as you follow the rules of algebra, you really can't mess up. Even if you thought this had to do with adding rather than multiplying, you still would have gotten the correct answer. Let's look at another problem. 1/5 x equals 4. We're going to have to deal with that 1/5 out front. Well, let's think about this in a different way. So what the problem has told me is that 1/5 x equals 4. But what I need to know is what is a whole x worth? So what I need to do is convert that 1/5 into 1. Okay, so what multiplied by 1/5 equals 1? Well, here's a little hint for you. Okay, so I hope you've gotten it. It would be 5/1. 1/5 times 5/1 equals 5/5, which is 1. And there's our correct multiplier. So we just multiply both sides by 5/1 and follow out the mathematics. Follow the rules of multiplying fractions, and you'll get 5x over 5 equals 20/1, or x equals 20. Circle your answer. Never understood why kids don't like circling the answer at the bottom. Sort of like planting the flag on Everest. Well, we've covered a lot of different kinds of one-step equations here. I think you guys... Oh. All right, well, let's do a stretch it question here before we finish up. Okay, 4/3x equals 8. Well, that's a little different. That fraction's a bit scarier than the ones we looked at before. But let's think about it like we thought about the last problem. Okay, we have that 4/3x equals 8. We want to find out what 1x is worth. So we have to turn 4/3 into 1. And the way we'll do that is by finding 4/3's reciprocal, or its multiplicative inverse. Okay, hey, like that one for free. So let's throw a hint in here. Okay, 4/3 times 3/4 is going to give you 12/12, which is 1. So there's the reciprocal. Okay, well, let's use our equation here, follow it out. 4/3x equals 8. Multiply both sides by 3/4. Convert those guys into fractions. So we've got 4x/3 and 8/1 times 3/4. Do the multiplication, do the reduction, and we find out that x equals 6. Whew, okay, not too bad. So this is just one-step equations, really easy ones. Next time we'll delve into things that are a bit tougher. So have yourself a great day.